Isaac, Melvin. If we do not talk, I'll just wind down the time and go about my business. So what's a blockchain? If you if you don't have an idea, you can say you don't have an idea. There's no wrong answers. There's no wrong answers. So I want us to interact.
Okay. Um, can you hear me?
I can hear you. I can hear you.
Okay. Uh, Blockchain. Um, I don't know how to say it without sounding technical.
I thought before I was supposed to be technical about it now.
Okay, okay. The blockchain is a distributed ledger system. Yeah.
Okay.
So it's it's like um it's more like, okay, an example in real life is like you have a store, and in your store you have somewhere where you keep all your records for maybe for your sales and transactions. Yeah. The blockchain is something like that. The only difference is that when you do that in your store, you can change things, you can alter things, you can erase or edit forever. Yeah, but unlike the blockchain, you can't alter anything, it's immutable. Yeah, so that's
Hmm.
what
You think you
blockchain is.
can't change the blockchain? You think you can't change something on the blockchain? Do you think that?
Mm, without um that's a bit complicated, sure. But let me just keep it like this. If you can
Okay.
change, I'm here to learn, sure. Yeah.
Mhm. If you can change it, say it's. I think it's because it's very expensive to change things on the blockchain. That's why there's no need to do that. Okay, so okay, that's also my pick. It's a distributed. It's a distributed ledger, yeah.
Yes.
It's a distributed digital ledger. Okay, so Isaac, how about you?
Okay, good morning. So me, I feel a blockchain has to do with decentralization. Right? Maybe yes, decentralized. And then I know that blockchain is also transparent. Then also again, blockchain is also secure. Yes.
But you haven't answered my question. You're telling me about uh, blockchain. Like you are telling me about it. I'm asking, what do you think it is? Like, what is a blockchain? You are saying a blockchain has to do with decentralization and stuff. You understand? They're like giving me like characteristics of a blockchain. You're not wrong. You're not wrong. That gets me. Don't think I'm saying that. I'm just asking you, what do you think is the blockchain itself?
Okay, so a blockchain is a decentralized ledger that helps or aids storing data.
Okay. Okay. Yes, okay, that's correct. It's correct. Mostly they'll tell you a blockchain is a decentralized digital ledger because when you're saying it's a ledger, it's a decentralized distributed ledger. I'm trying to open up some notes that I can use. I think it's decentralized, it's distributed, and it's immutable. A decentralized, distributed, and immutable ledger. Decentralized in the fact that no one has complete autonomy over it. Distributed as it is available across multiple nodes, and it's what's the third one is decentralized, it's distributed. A ledger it simply means it's a record of um, it's a record of yeah, it is a record. So let me share my screen. I think I have the Ethereum documentation opened. So is there any confusion or we can proceed? Can you see my screen?
Yes, you can see us.
Okay, so let me just increase the font size so that we can see. So what's a blockchain? A blockchain, just like we've said, is a public database that is updated and shared. Okay, that's the distribution we're talking about. Um, Updated and shared across many computers in the network. A block. So okay, so I think here's breaking down the key terms of the block. So the block refers to data and state being stored in consecutive groups known as block. So how the concept of a blockchain work is you have data on transaction. If you want to perform a transaction, when you sign the transaction, it goes into what we know as a meme pool. Do you understand the concept of meme pool? Does anybody understand the concept of a meme pool? MEMEPOOL.
Yeah, I think so.
Okay, so what do you think it is?
I'm
Like,
not.
you know, you see, you don't need to
I
be
think
sure. That's why you're learning. So yeah.
okay. So I think a meme pool is like would I say purgatory? It's like a
Mm,
place um where maybe data is stored temporarily before it now like moves to the blockchain permanently, something like that.
okay. Yeah, you're on track. But you said purgatory. Me, I would say lobby. So I would say a main pool is like the waiting room for data. It is where data is like all the data that want to be added to the blockchain. It is where they are, and they are added to each block. Each block is like a storage. So when the block is filled up with data, then they are added to the blockchain. So here they say the block refers to data and state being stored in consecutive groups known as block. If you send it to someone else, the transaction needs to be added to the block to be successful. Yes. So the chain refers to the fact that each block cryptographically represent its parent. In other words, blocks get chained together. The data is in a block cannot be changed without changing all subsequent blocks, which will require consensus of the entire network. So yeah, I think each block is linked because I think the data that each block takes is it has to take the transaction hash of the last block, or is it the block hash? So each blocks, all these blocks are linked together. And that's why you can have a blockchain. So it's just like if let's say we have I'm trying to okay, if block A gets filled up before block B is being started, it is being linked with the last hash from block A. When block B gets filled up, block B's the first block, the last hash of block B is being linked to the new block C. So that's how we have a chain. So that if you go back, it's not that you cannot go back. If you go back to block B and change something, it corrupts the whole system going forward. Unless if why I said it's expensive is if you want to correct it, that means every other person has to correct it and will mine all the data that have been put in. So every computer in the network must agree upon each new block and chain as a whole. The computers are known as nodes. Nodes ensure everyone interacting with the blockchain has the same data. To accomplish this, distributed agreement blockchains need a consensus mechanism. Okay, yes. To accomplish this distributed agreement, blockchains need a consensus mechanism. So now we've spoke about the main pool and a new topic has come in nodes. So nodes, like my boss, Mr. Dave, will say, he said, okay, nodes are computers. They are high computers that enables new blocks to be created, adding transaction to blocks from the main pool. So in order for you, once you run a consensus client and an execution client, there you are a node. And in Ethereum, I think they need to stake 32 ETH to be able to perform that. So now it's not about going to the main pool and packing transaction and putting in and loading a block like you do a boss. That's it. You have to be sure that you have to be sure that you validate the transaction and make sure it's correct. So the way this is achieved is what we call a consensus mechanism. So everyone has to come together and agree, okay, this is This is how this should be done. So they said Ethereum uses the proof of stake based on a consensus mechanism. So if you want to add new blocks, everyone is open, like you're welcome to add new blocks. Anyone who wants to add new blocks to the chain must take ETH. So I know most people will be saying I have one Ethereum, one Bitcoin. I think that's wrong. Why? It's not wrong, sure, but it's out of context because if it and Ethereum are two different things, or you call it Ether. So Ethereum is the blockchain as a whole, while ETH or Ether is the native currency. You know, there are other denominations for Ether. We have GUI, we have WEI and stuff. Yeah. So the native currency, okay, you have to stake the native currency in Ethereum as collateral to run a validator software. So these validators can then be randomly selected to propose blocks, and other validators check and add to the blockchain. This is a system of rewards and penalty that strongly incentivize participants to be honest and available online as much as possible. So yeah, you stake that to it, and for each block you validate, I think you get rewarded in it. And for each block you try to act malicious in, your stake is slashed. If you act too maliciously, they can take away everything that you have. So yeah, okay, I have this demo. As I was teaching, I've been thinking of how to get to this demo. But yeah, is there any question before I go ahead? Is there any question
No,
before continue? So what
no,
consensus
no.
mechanism does Ethereum use?
Proof of stake. Proof of stake.
Okay, first proof of stake.
From what you said so far, so I
Yeah.
think now proof of stake is a way whereby Ethereum uses, whereby validators take Ethereum so that they can add more, or they can validate blocks in the Ethereum ecosystem.
Okay, so who can tell me about another consensus mechanism that you use?
I think that for Bitcoin, I think we have proof of work. Yes.
So what's proof of work?
I know that proof of work now has to do, okay. I don't know how to put it here. That
There's
okay,
no wrong
I don't
answer.
know I don't know
Just say it.
how to okay.
Okay, so
So
okay, let me help you. Let's see. So proof of work is when, in this case, in proof of stake, we have validators which create new blocks by adding transactions from the main pool to blocks. So in proof of work, here they are not called validators, but they are called miners, and miners solve complex mathematical problems. So they could add new blocks. So by solving such complex problems, they are rewarded in the native token. So like Bitcoin uses the proof of work, and the reward guys with BTC. Then I think there's another one. I've been working with Core. So Core is also a layer on blockchain, and the consensus mechanism they use is they use the Satoshi consensus mechanism, which includes the delegated proof of work, delegated proof of stake, and the non-custodial staking. So that's their own consensus mechanism. So good. Let me show you a little bit of how a block work. So let's start from hash. What's a hash? What's a hash? When you see a hash, what's a hash? Any idea? Blessing Emmanuel, any idea what a hash is? And Genesis Pray. I think I've just been speaking with Emeka and Louis. Yeah. Unmute your mic, please, and let's talk.
Hello, good morning.
Morning. So we've been speaking about the blockchain, and it has landed us in what is known as a hash. Do you know what a hash is? HASH.
No.
Okay. All right. That's why you are here, though. Blessing. Any idea? Melvin. Any idea? Oh, wow. So okay. So I think a hash just let me see. I want to say it off the top of my head and I'm missing it. So a hash is just like let's say it's this SHA-256 hash is, let me think. I'm thinking of the right word to use. Now I understand, Isaac. So let's say you want, it's like a coded message. Good. Let me just use it like that. Let me just say that a hash is like a coded message. So let's say I want to type something, but I don't want you to know what I type. It's the concept of the public key and the private key. So wait, let me just get a hash here. Cryptographic hash. Yeah. So let me not use my own words and confuse anybody. So let's say you want to encode a message. I think from time immemorial, people, yeah, good. So it's a function that converts data of any size into a fixed string of characters called a hash or digest. Okay. So a hash, yeah, all hashes are of the same string length. You see here now, this is the hash. So if I start working on it, you understand what I'm trying to say. So a hash is like an encoded message. So now let's say I want to say I. You see the hash has changed, but the string remains the same. Let me say I am a boy. You see the hash keeps changing. So this is the representation of I'm a boy. See what happens if I change this B to capital letter. You see the hash changes. Even if I add a space, the hash changes. So a hash is like it's like the result of an encrypted message. Yes, let me just say it. When you encrypt a message, like especially the SHA-256, is used to encrypt messages so that people cannot know what you are passing on. So you see now, if you come and you see this hash, you wouldn't know the message I'm passing unless you have the formula that I use to hash it. So it's always a fixed string, a string of fixed length. So that way you are not able to like now if you see this a string of students, you don't know how many characters, you cannot guess how long it is or how short it is. So now to the let's go to the concept of a block. So now you see a block is made up of the hash. So every message, every data you input in a block has its own unique hash. But for it to be valid, it has to start with 4 zeros. Can you see my screen, guys?
Yes, we can. I
Okay,
can.
so it has to start with 4 zeros for it to be valid. I think the nonce is the number of transactions that have occurred. Yes, I think the nonce is how many transactions you have done, is a transaction count. So this is the concept of a block. Let's say in this block, we want to say adjacent John $500, $500. Huh? You see now the hash has changed, but the block is right. So now for this block to be successfully added, I have to mine the hash. I have to look for a way that I will make this to start with 4 zeros. So normally in the proof of work, there are complex computers that handle this, but I can just mine. If I mine, this is what mining does. So now it's going to mine it and it's going to get a correct hash for this message. I don't know why it's taking this long. It's supposed to have done that. Exactly. So let's wait. So when you pass in data, you mine it. So then you see the block turns green and you get a new hash. Good. You see, it has gotten a hash for me, and the hash starts with 4 zeros. So now this block can be successfully added to a blockchain. So let's go to the concept of how the blockchain is now. So now we've deal with a hash. The hash is like just the encoded message of the transaction in the block. Are we together?
Yes.
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 Any question? I think I've passed in a lot of information. Is there any question before I move ahead? Confusion? Like there's no foolish questions. I'll answer anything. If you don't understand, just say the word. Okay. If we're all good, at least let me see emojis so that I can continue. Okay. Emeka is good. Okay. Indificate. Okay, everybody, nice. So now this is a blockchain now. This is how a blockchain looks. We have blocks cryptographically linked together. We have 5 blocks in this blockchain. So let's see how it works. So now here, let's input the data. So good. The blockchain, I told you every block carries the hash of the previous block. The hash of the previous block will be used to build the new block. If you pay attention, you see this hash is the same as this hash. Then this block is hashed, and the previous hash is used to create the next block. The same thing with here. The previous hash, this is the hash 62. It's used. So that's why it's called the blockchain. So let me show you now. So all these blocks are empty currently. So let's start putting information. Let's see here, John is a John was paid. Okay, let's see. Pay John 1,000. You understand? So disregard the colors of the rest. So now we mine the block. So let's say now I pass as my colleague, I pass in an information to you. I said in the first block, I was like, pay John $1,000. So now I've mined the block successfully and it's on the blockchain. So, okay, this hash is the same as this now. So I now said pay Mary, let's see, 10,000. We mine this information on the blockchain. It's okay, you see, it's now correct, you understand? And I'll come here, I'm like, pay Joy 10,000 too. Mind you, I didn't make a mistake when I was saying pay John. I didn't make a mistake. I know what I was doing. I said pay everybody 10,000, but give John $1,000. So let's say, the blockchain is distributed, it's decentralized, and everybody can see. So John, let's say John comes in and he feels unfair, like they say made them pay Joy 10,000, pay Mary 10,000. Why are they paying me 1,000? So let's say it's Indy that is supposed to make this payment, and he's going to be the one that will come, and maybe payment will be made in the morning. So John was like, okay, me, I'll not just change my own to the 10,000 to mirrors everybody's own. Because like in our system in Nigeria, it's not going to be hard now. It's just to add 1 0, isn't it? And guys, it's just to add 1 0 now, and everything has changed. So let's see now. So John will now come back to the first block and add 1 0. Do you see what has happened now? Guys.
Yes.
You see the whole blocks, everything has spoiled. So if you now come now, let's say you come to make payment. You see the block is red and there's a problem. Do you get me?
But she can't copy this thing well, though. This removing of funds and all.
No worry. So even if you mine this block to get the correct hash, let's mine the block so that we get the correct hash, because you need to remine all the blocks. So that's why I was telling Isaac that to change information is not hard. It's not that it's not possible, it's just too expensive. So even if you come and you mine this block, you have to mine this other block and mine this other block, and so that everything becomes correct. But let's say we go back, let's make it back $1,000. The normal money is supposed to be paid, and we mine the block. Yeah, you see, everything is now legit. We haven't passed in anything here. So do you understand the concept of this, like of a blockchain, just a blockchain, according to what I just did? If there's any confusion, I can try it. Everybody's good, yeah? So now let's talk about, now you would think that if John changes his own to 10,000 back, let's change it to 10,000, and he reminds the block. Let's say he reminds his own copy. So in this case, the person doing this is a validator, mind you, let me correct you, because not all of us is the person that is adding the transaction to the blockchain that is doing this thing. So if he does this in a normal day, they will punish him. But let's say he does this, he's made his own 10,000. He will make Mary's own too. He minds, let's say he changes it, he reminds every block. It's possible. Then he reminds every block. I don't know why the mining takes time. It's not supposed to be taking this long. Good. And he mines the third block. And Indy comes to pay them the money, and everything is green. It's like, oh yeah, now I can pay the money. But I'm going to show you where the problem comes in now in the next tab. So I just want to show you that it's possible they can remind. Good. All 3 blocks are green. There's no data in the fourth block, so don't worry. So it means we're all good. But that's where distribution comes in now. The problem is it's not only you that have a copy of the blockchain. So that's the main thing. It's not only this guy that has the copy. So you might be doing something else on yours. You see now, so you see, now we have, let's see, this is PSC. Let's say we're working with 3 nodes. So the way the blockchain work is every validator is selected in every epoch. I think every 12 seconds, every validator is selected to create a new block. You understand? Are we together? Okay, so I think it's every 12 seconds, every epoch, a new block is created, and a validator is selected at random. Let's say now, we'll say, okay, Melvin, you're creating the next block. After Melvin, Emeka is creating the next block. After that, Theo is creating the next block. But this is the funny thing now. Anything you do during your time, everybody's going to do the same thing. So if you said, okay, this time we're going to follow, let me say we want to go to town from, let's say we want to go to, I'm trying to think. Let's say we want to go to, I'm trying to look for a universal thing that everybody understands. Let's say we want to go to the gate or any house and want to go from the room to the gate, and it's Melvin's turn to create the block. So in essence, it's going to be like Melvin is going to tell us the road we're going to follow. Okay, Melvin, they said, okay, we're going to go through the parlor, then we'll go through the front door, and we'll get to the gate. He follows that part. Everybody is going to do that thing the same way he did it. And you cannot come and tell me when you pass this, you didn't, like, okay, it's out of context. I'm trying to look for example. So everybody does, okay, let's say the next block is 10 times 10. But Melvin is going to do 10 times 10. And Melvin does 10 times 10. The other validators will have to mirror that transaction. They are not going to copy Melvin. They are going to do the transaction themselves. They're going to mine for their own hash. So if Melvin now do his own and said 10 times 10 is 100, Emeka said 10 times 10 is 100, everybody says 10 times 10 is 100. Then somebody now stand up and say 10 times 10 is 20. You see, his own block will look different. So let me show you now. So good. This is the block 1. Let's say John is a boy. Then he mines it. As he does that, everybody now will have to do. I don't know why the mining is taking this long. It normally doesn't take this long. Okay, it's the page that's unresponsive. It's that page that's an issue. Sorry, the page. I thought it was my system, but it's the page. Everybody is moving. Okay, good. So the page has been mined, I think. So now, you see, he has mined. If you notice, the block number is 1. Okay, it hasn't. The block number is 1. The nonce is 11316. Okay, this one, the nonce is different, but the block number is 1. So now, for this to be a blockchain, this guy has to do the same transaction. John is a boy. Everybody has to do the same transaction and mine it. So, okay, I cannot put a transaction here. Like everybody, this is how the blockchain is supposed to look. It's taking time. Okay, I'll work with just 2 blocks then. Now we don't to be doing it in 3 places. So the concept is if I want to do this thing one by one, it's taking too much time. So everybody is going to have the same block. But the problem now comes in when, let's say, the block 2 for the pair B, it's different from the block 2 in the other pair. So that's when you now be seeing, if there's differences now, then the people will now know that this your block cannot be trusted. So that's why you have to maintain 32 At the end of the day, everybody's supposed to have the same copy of transactions on their own nodes. And this is so that in case the network breaks, there cannot be a complete down. The network cannot completely be broken because at least there's going to be a surviving copy of the blockchain. Let's say there's a disaster somewhere. At least there's going to be a node in another place that people can come and continue from. So good. I think I don't know if I had confused you or but I think I'll give you guys this that you guys can practice it on your own time. I'll drop it in the chat so you can practice it in your own time and you understand. So good. I think okay. So what is Ethereum? Ethereum is a blockchain with a computer embedded in it. It is the foundation of building apps and organization in a decentralized, permissionless, and censorship-resistant way. So we've been talking about the blockchain. So now we're talking about Ethereum itself. It's a blockchain with a computer. It's a supercomputer. I think they call it tuning complete. Yeah, I think it's tuning complete. Good. In the Ethereum universe, there's a single canonical computer. It's called the EVM. That's the Ethereum virtual machine. I think you hear it's EVM compatible. It mirrors Ethereum virtual machine. So the thing is, Bitcoin is a blockchain, but Bitcoin it does not support the building of applications on it. So that's where Ethereum Bitcoin is backed up by strong security and mainly supports transactions. But Ethereum, it's decentralized. It allows users to build applications, decentralized applications on it. So additionally, okay, yes. So Ether, as I told you guys, Ether here, or I call it ETH, that's the symbol, ETH, is the native currency of Ethereum. The purpose of it is to allow for a market of computation and stuff. So then we can go sorry, I'm rushing you guys, but I think I'm too slow. So then we have smart contracts. So what are smart contracts? I know all of you are familiar with smart contracts. What are smart contracts?
Contract that are smart.
Not you in the fake, please. Bubai Yakubu, what are smart contracts? Don't be ashamed. Please, there's no wrong answer. I used to say this thing, just that's the easiest way you can learn. Just say something, anything that comes to your mind. Bubai, please, I'm waiting for you. I'll mute your mic. Thank you. Anybody that did not talk, Shay, we used to do attendance, Indy.
Yes, sir, we do attendance.
So anybody that did not say anything is as if he was not in class. Somebody can just open his browser and just leave his system. So Mark. Okay, Theo, you want to say something?
I think.
Okay, Mark, I'm with you. Theo, wait for Mark.
Smart contracts are like digital agreements run by themselves in the blockchain.
You said?
I said smart contracts are like a digital agreement that are run by themselves on the blockchain.
Smart contracts, they run by themselves. Yeah. Are you sure? They run by themselves. We're talking now. Indeed, do you think smart contracts run by themselves?
Um,
Wait, what do you mean by run by
Yes, they are
themselves?
self-executing.
how
Okay.
about like like set of instructions like used for um, automation?
Okay, yeah, set of instruction. Yeah, I like this guy. So I think, oh, it's been a while. Me, I thought I could come and graze through this class without much research, but the definition of some key terms are just missing. So okay, let me remember what I remember. They said, do you know what they call the pinky swear? When we're small, that's that one that will clip your pinkies together and like. I swear I'll not disappoint you. I don't know if you understand. What's the contract? Let's start from the let me walk my way down. What's the contract? I'm not saying smart contract now. Theo, what's the contract?
I don't know. The contract now you're asking, is it just normal definition of
A
contract?
normal contract. What's the contract?
Okay,
Okay. A
contract
contract
is
is
just
like
like
the
a
terms of
formal.
agreement between person.
Okay, an agreement between two people, yeah. So I think even you and your app providers, sometimes if you download an app, they'll tell you agree to terms and conditions. Like if you get a job, they give you a contract to sign. If you even marriage is a contract, so yeah, I think marriage is a contract now between two spouses that they are going to be together. So yeah, it's true. But even the government do enter contract with people. But what's the issue with contract? Most contract fails. Like I might come in and come to, let's say, a landlord and a tenant. So I'm looking for a house. Indy has a house. And like Indy, I would like to rent a room from you. So let's say I was working in a good organization, earning good money, and I'm good for his house rent. Let's say I earn maybe, let's say 10 million, 12 million a year, and in this house is maybe a million a year. I'm like, yeah, I'm good for it. I make 12 million annually, so I'm good for it. In this, like, yeah, it's true. I know this guy, he's good for it. So I come in, he gives me my tenant agreement. I sign a million a year. 1 year I pay 2, 3 years. So somewhere around, let's say the third year, let's say I was in an accident. I lost maybe my hands, and maybe not type I did type, and maybe the small savings I have, I used it. I paid for medical bills and everything, and I don't have much money. I haven't paid him his rent, and he understood, like, this guy is struggling, so I paid rent. And the next year is coming to an end now. I don't have 1 million now. I start touching in the freaking. You see, agreements and contracts can be broken. You understand? Agreements and contracts can be broken. Like, what I'm trying to say is they can be broken even if both parties have the best intentions. So now in the freaking news, this boy is true, it's true. He did pay, the default. But in the freaking too, maybe he has his own issue and he needs my rent. In the you understand? We have an agreement, but still the agreement can be broken. Even the government can promise
But boss, I
workers
don't
that.
understand though. You pay your rent too.
So you see now, but he doesn't even understand. So even government will give lecturers jobs and say, we'll pay you this, we'll pay you that. After a while, lecturers will now come out. The government is refusing to honor their agreement to we're going to go on strike. So even as kids, we say, we'll be best friends forever. They do pinky promise, we'll hold each other hand, and yes, we'll be BFFs. And maybe somewhere around the line, they'll go and follow your girlfriend. You understand? So don't scatter be that. So what am I saying now? The world moves on agreement, and without agreement, you cannot go far. But the problem with agreement is it's that they are easily broken. But what the blockchain does is, like, okay, Patrick Collins says smart contracts are like pinky swear. I swear I will do this. So instead of you now promising me that I'll pay you my rent at the end of the every calendar year, we can just write a smart contract that at the end of the year, it's going to debit you and credit me. And that contract, as long as it's running, as long as the conditions are met, it will come to pass. Like, you don't need promise me, no worry, you don't need promise me anything, just put down for smart contract. I don't know if you understand the concept now. So a smart contract is an agreement that I dare say cannot be broken. It's an agreement written in logic, embedded in the blockchain, and it must be fulfilled. It's a promise that must, I can guarantee you, it's a promise that must be fulfilled if the conditions are met, except the conditions are met. Okay, so in practice, participants don't write new code every time they want to request computation. Rather, application upload reusable snippets of code into the EVM. Okay, what's up? Ahead, Willem. Indy, what's up?
Okay. I wanted to just ask, to just help clarify in case anybody's confused. The idea of billing, things like Spotify, billing, Apple Music, um, Netflix, and all that. Is that the billing process of these things that happen monthly? Can we use that in a way to explain how smart contracts work?
Okay, I'm trying to see. So, okay, I'm trying to, the way, so yeah, like, let's say now, that one is, yes, so let's say the way they bill you, it's automated, yeah? So that's like logic. At every end of the month, call this function. Once this time has reached, call the debit function. And I even think they are more lenient. I think if it's on the blockchain, the moment, even though you are watching, you see Netflix will give you 5 months grace, 5 days. They give you 14 days self bar. But I think if it's a smart contract, you just cut your access at once. Because it's going to be like, as long as you don't have a subscription, you don't have access to these services. So yes, so at every, like, if that was written on a smart contract, at every end of the month, it calls the function, debit this user's account for so and so amount, so that these services can be accessed by said person. In the hand is still up. Indy.
Sorry, boss, was a mistake. Let me take it down.
Okay, good. So let's see what the said smart contracts are. Okay, you can think of it like a sort of a vending machine, a script that when called with certain parameters performs some actions or computation if certain conditions are satisfied exactly. For example, yeah, yes. So I think, okay, this is a review. Blockchain, a sequence of blocks, okay? ETH is the native currency, EVM is the global virtual machine. Yeah, hope I'm not too fast. Okay, good. So accounts where Ether is stored, users can utilize accounts, deposit it into the account, and transfer it from the account. Yes, we all know accounts now. Then transactions, like I think transaction request is a formal term for a request of code execution on the EVM, and a transaction is a fulfilled transaction request associated with state change in the EVM. Associated in the EVM state change. Okay, so let's see. I think I have something that I did somewhere. I just pray I can work it. Let me just show you what it means. Let me show you what it is. IE. Let's see. Okay, good. I think I have something that I've been working on that I can use to explain what a transaction is. So now, there's a transaction is you should know what I have money. Uh-huh. Okay, good. Yeah, so I think this is a game I've been working on. I'm coming. I just need to, I want to use it somewhere so that you understand. Let's disconnect. Okay. So we can have one test page. So let's connect wallets. Let's use my browser's wallet is connected. So let me go to this page. So now, good. Let's see now. This is on StackNet though, but it's going to still give you a concept. We're talking about transactions. So now, if you want to effect state change on the blockchain, you do a transaction request. So I'm going to let me explain that for you. So what is who can tell me what state changes are? What's a state change? State change, somebody please, state change. Okay, good. This guy is not registered. What is state change? So on the blockchain, there are two types of transactions. We have read transactions and we have write transactions. So read transactions are when you are requesting information from the blockchain. They do not alter the blockchain. They just give you a snapshot of the information you're requesting. While the other type is a write transaction, it's when you want to make changes to the blockchain. They are expensive. They are not expensive, but they cost gas. Okay, they are expensive in Ethereum back in the day, but we have solutions that have made them cheaper now. Are you guys together? Please read and write transaction. Did anybody understand, or I should clarify again? People guys are quiet too much. I don't know if I'm making sense or confusing you. Boba, you refuse to talk. You're doing me thumbs up.
Okay, you can clarify to make it simpler. Just
we have
use football terms or
okay.
something.
We have two types of transactions. You understand? A transaction. I don't like the Ethereum book I'm using is just a little bit I just want to pass in the information directly. So if you want to make, we've been hearing about the blockchain. Good, we've been hearing about the blockchain. If you want to add this information to the blockchain, that means you want to write to the blockchain. That's one type of transaction. If you want to collect the data back from the blockchain, it's a read transaction, and it does not require it requires little to no gas fee. So good. Let me use this as an example. I'm good. So I read get player from the blockchain. See, this is the response. The ID is 0. The username is 0. The inventory is 0. Everything falls 0, 0, 0. So this is a game I've been building. So let's say I want to register now. The username should be Indy. So now, you see now, when I get player, it's 0. Indy, I want to give one of my address to that. But now, if I register Indy, you see, I'm calling this and you see it's loading. Please, can we see the loading? Like, I need to know because it's very critical. Good. So it's loading. So now, if I register player, I'll see something different now. You see, do you see some, like, who can see what happened? What's the difference thing that happened? Someone should just say it. Who noticed a difference? What happened differently? Please, 3 others. Let me see.
It sent a sign-in message to the wallet.
Exactly. So this is a write. Now it means I want to. So now registering means I want to create a new player on my game. Understand? This is just the console. This is not the real game. Don't worry, I'll show you guys the game later. So, so this is it. So it's going to it's prompting me to sign, and you see I'm going to pay a fee of about 0.024 stack, which is roughly so negligible in dollars. So I signed this transaction. So now me signing this transaction, you see, it's taking time. It's me. I'm writing to the blockchain. You see now, the transaction has been sent. This is the transaction hash. It returns the transaction hash because I've initiated a transaction on the blockchain. If I go to stack scan, let me go to Voyager now. Voyager. If I go and search for this transaction hash, it will show you all the details of the transaction. Come in. Search for it like that. So you see now, this it shows that okay, I have registered the player as Indy. That's what I did now. Since it has shown successful, let me get the StackNet this converter. Sorry, I don't know why MTN is like this. I want this thing to load. So Sorry. It's taking forever. Okay, good. So this is the transaction hash. Why is it telling me it's a contract? Okay. Yes. I'm coming. This is the transaction. Good. So you see now, this is everything about that transaction. This is the sender's address. This is the fee, the time 2 minutes ago. You see now, it's now telling me it's telling me I called a function register. Can you see? On this contract, and this is the clash hash. Please, do you guys understand? This is the username felt 252. If I copy this username now, if I copy it out now and I go to here and I paste it, no. How do I get it back? Let's see, 513751. 513. If I do indie, you see, 5137513. I'm coming. Let's see. This hash. I know this converter doesn't have the reverse function. I need the reverse function. Let's see. No, it doesn't have the reverse. It's just a one-way converter. Okay, but you guys get the gist now. If I make this indie, we get 5137513. Then you see it, we have it here, 5137513. Do we understand? It's no emoji. Nobody understand. Okay, well, 3 to you. Thank you. So you see that's right transaction. So now you know I've registered indie at this address. If we get indie now, you see, okay, plenty people have used this thing. So indie his ID is now 10. This is his username 5137513. So this is not yet verified. So in the game on registration, we give you an aquarium, we give you one fish, we give you decoration count and the time you registered. So if we want, we can add an aquarium for indie. You see, okay, if we do new aquarium, you see, it's telling us to sign another message because we want to create something new on the blockchain. Do we understand? But anytime I want to read from the blockchain, I don't need to sign any transaction because I'm not altering the state of the blockchain and it's cheaper. It doesn't bill me. Are we together?
Yes.
So good, I've written it. You know, in the beginning, it had one aquarium, but if we do get player, you see now he has aquarium count is 2. So this is how, I think this is how you, like this is the difference between a read and a write transaction. Are we together? Any question, please? Like I will take questions now. If we do not have questions, we will end the class. No question. Okay, bye. Ask your question.
Yes, sir. About the read and write transaction, please can you come again? I did not really get
so
it.
Now I said there are 2 types of transactions. Okay. Let's see. Let me go to the console of the game. Again, let me explain to you. There are 2 types of transactions. One adds information to the blockchain. The other one gets information from the blockchain. Are we together, Bobai?
Yes, sir.
So transaction is just when you are like, I'm doing this in my head too much. Let's read. A transaction, okay. A transaction request is the formal term for a request for code execution on the EVM, and a transaction is a fulfilled transaction request and the associated change in the EVM. Any user can broadcast a transaction request to the network from a node. For the transaction request to be effected, the agreed upon EVM state, it must be validated, executed, and committed to the network by another node. A transaction, every time you call a function, are you hearing me? Just imagine every time you call a function on the blockchain, you're executing a transaction. Yeah, that's what a transaction is. Anytime you call a function, are you getting me?
Yes, sir.
So let's say you want to transfer money. Once you click on transfer, that's the transaction. That's what most people understand as a transaction. But anytime you call a function, so we now have two types. We have the read and the write. So the read now is when you perform a transaction that will return data from the blockchain. You want to query data. You want to see, hey, what is inside here? Are you getting me?
Yes, sir.
What is inside there? Then that's a read transaction. It doesn't cost much because you are just retrieving information. The expensive transaction is the write transaction. So a write transaction allows you to change the state of a blockchain. So like now, if we read about this player, let me go back to the free case account. If we read his information, like we read his information now, we do get clear. You see, a read transaction. You see, it's loading, it's getting his information. So this is his information. This is his wallet address, his ID is 10, this is his username. Everything is he verified. He has 2 aquariums, his fish. This is reading work. It's just like a read transaction, like collecting somebody's file. A write transaction is altering the changing stuff on the blockchain. So now let's get a new fish. In the which type of fish do you want? We have goldfish, angel fish, we have beta, non-terra, and corridors. Don't say catfish.
Croaker fish.
Titus.
Titus. So good, let's get a new fish for Indy. Let's get new fish. You see, currently the fish count is 1. So now we want to change the state of the blockchain. We want him to have 2 fishes. We want to click on new fish. You see it will load. To load, and I sign the transaction. So this transaction is asking me for gas. So now from there, we'll go to the concept of gas. This is a write transaction. So it has effected change on the blockchain. So now if we query Indy, you see now he has 2 fish. Do you understand?
Yes, sir. Very clear.
We wrote to the blockchain and we read from it. So good. So now, so we've talked about blocks, blah 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 blah. So the EVM. So now I just mentioned something, gas. So what is gas? What is gas? Gas refers to the units that measure the amount of computational efforts required to execute specific operations on the network. So now we've been talking about signing a transaction. So if we want to do new aquarium now, if we want to create a new aquarium, the EVM will calculate. Okay, let me use this example they always use for us then. They said if you want to go to Lagos or if you want to go to Abuja, now you do your math. Okay, if you want to drive or you want to use public transport, you do okay now. How much go carry me go Abuja? You now ask, okay, how much is the transport? Transport is, let's say, 10,000 naira from Kaduna. You'll be like, okay, do I have 10,000 naira in my account? If you check your account balance and you're seeing 6,200, you see that in your house. You're not going anywhere. So that's how the blockchain works. If you want to initiate a transaction, the blockchain is going to calculate the amount of gas that will take him there. So let's say now we're driving. Like me now, I schooled in Jos and I used to drive. I drive between Kaduna and Jos mostly. So I know that 30 liters of fuel will take me to Jos from Kaduna. So that's the gas. So the gas now is the unit of computational work that is required to execute a specific transaction or operation on the Ethereum network. So now I know if I'm going to Jos now, I need 30 liters. Anytime if I want to go to Jos, I know I need a minimum of 30 liters to take me to Jos. So then now, people will mistake gas and gas fee. So now, gas fee now is the price of the unit of gas needed. So now, I know that per liter. I think then I need about 5,000 naira worth of fuel to go to Jos. Yeah. So you see, then now the gas is 30 liters, but the gas price is 5,000 naira. But now I think I need close to 30,000 naira, around 28, 29,000 naira worth of fuel to that commute. So that's the difference between gas and gas fee. Gas is the measure of the effort needed, and the gas fee is the cost. Do we understand?
So
Anybody that okay, so gas is the computational, is the a measure of the computational effort required to perform a transaction. Like the measure is the unit is the measure of the amount of computational effort required. Like, okay, what will you need to get this work done? Let me say you're an engineer now. What would you need to fix my car? You say I will need to buy new tire. You understand? That is what you need. So the price of the tire now is like the gas fee. I don't know if you get my point. There's a unit of computational effort. Then the fee is now the amount of gas used to do some operation multiplied by the cost per unit gas. So I said we need 30 liters I need 30 liters of fuel to drive from Kaduna to Abuja. That's the amount of fuel used. So the gas fee now is the amount of gas used, so 30 liters multiplied by the cost per unit gas. So we know fuel is 945 per liter. So the gas fee now will be 945 times 30. Does it make sense, please? I cannot see. I do not. It makes sense. Emojis. Let's see. Okay, Genesis, Popeye. It's only Genesis and Popeye that is inside the class. Okay, Theo. Who's here? Marianne. You understand? Okay, good. Marianne, thank you. Unmute your mic and tell me the difference between gas and gas fee.
Okay, so according to what you said, gas is why gas fee is the cost, like how much you are paying.
I didn't get that. I didn't hear you clearly, please.
Sorry, can you hear me now?
Yeah, I can.
So you said gas is the measurement, right? Why gas fee is the cost
Measurement of what?
of. Okay, I didn't get that there.
I don't understand. Can someone help her?
Okay.
Theo, you want to help her? No, Chuku. Obed. Yeah, please go ahead.
Jimbo, can you hear me?
Yeah, I can hear you.
Okay, so gas itself is a measure of the computational power.
Okay. Then what's the gas price? I can't hear you if you are saying anything, bro. Okay, people don't like talking, no problem now. So, okay, we're done with gas and gas fee. So we've talked about the consensus mechanism. I think, okay, then let's talk about storage. Let's talk about storage. So we've been making noise that it's a distributed ledger. So it means that it's like a storage, yeah? Are we together?
Yes, sir.
Okay, good. So who can tell me the types of storage we have when we're working with the blockchain? Nobody. Wait, have you ever written a smart contract? I want to see show of hands. No idea, Bye. Wow. Wow. So you guys are baby. Okay. Today was supposed to be an introduction class. Okay, so I'm not going to push more information into your head. I'm going to push information into your head. So okay, let's do a recap. Let's discuss. So I'm going to start one after the other. Bye-bye. I'll meet your mic. You are the first person I can see. Why you are the first person I can see. So yeah, just give me a recap in like a minute of what you've learned today.
Okay, so I got to understand how that's for the transaction, how the read and write transactions actually operate. That's just what I could learn because I
Okay,
joined
so
the
tell me what's the read, what's the write transaction again?
you said the read transaction is when you want to obtain information from the blockchain,
Okay.
while the write transaction is when you want to perform a transaction when you want to perform a transaction within the blockchain to another.
No, sir. And you said, you're gonna put me side trouble somewhere. Is that what I said? Bye. The right transaction is a transaction that it's when you write to the blockchain, you are altering the state of the blockchain. So the right transaction is a transaction that causes change in the blockchain. Any change, and for change to be effected, the cost of effecting that change is calculated. That's what it's gas, and the fee is the amount you pay for it. That's the cost per unit gas multiplied by the gas. Did I just confuse you more?
Yeah, a little.
So a write transaction is a transaction that causes state change to the blockchain. A read transaction gets information from the blockchain. Write transaction alters the state of the blockchain. That's if you are adding something to the blockchain, you write. If you want to get what is on the blockchain, you read. And the write transaction, for you to change something on the blockchain, you need gas. Do you understand?
Yes, I do.
And the gas fee is the price you pay to effect the change. Obed, welcome. So tell me something. Thank you, Boba. You can unmute. You can mute. Obed, okay. Obed is absent. Isaac. Okay. Isaac is absent too. Genesis.
Good morning, sir.
Morning. Please don't
Okay.
tell me you learn read and write transaction. No, please. I continue.
Okay, from the time I joined the class, I learned how chains work. You're explaining blockchains and how each transaction is a block, and then together they are blockchains. And then you talked about validators too and the work they do.
Okay.
Then
So what's the difference between a validator and a miner?
okay, so a validator.
Yeah.
How do I explain this? I don't know how to explain it.
Anyhow, just okay. I'm
Can I
not
go?
that new, so go. Okay, you want to run away?
No, I don't want to run away. There are other things I've learned.
Okay, continue then. I'm with you.
Okay, then you spoke about transactions. You spoke about write transaction and then read transactions. Somehow, when you're explaining it, I was able to like relate it to my prior SQL knowledge, and that's how I was like really following. Write transaction is like querying a database. So I want to see I want to see a particular
That's read
thing.
transaction.
That's read transaction.
Yes, when you query data to see what's there, you read from it.
Okay, then write transaction is altering. Let's
Adding,
yes. So imagine I want to alter
exactly.
a database now. That would be me writing a transaction. And
Yeah.
then gas and gas fee.
Okay.
You said the gas is the computational effort required to execute an action. So if I want to go to Jos, I need fuel. That is, let me say, the effort now. And then the cost of the fuel would be the gas fee. So the fuel that I need is the effort. That would be the gas. Then the gas fee is the price of fuel that I need to go to where I need to get to.
Excellent. Yeah, plus. I didn't waste my time. That's wonderful. That's wonderful. Please, people should give her a hand there. At least oh, I'm raising my hand. Oh, Jesus, where is that emoji button? Yeah, like yes, take your flowers. So Marianne. Sorry if I did not pronounce it well. So yeah, okay, Marianne.
Sorry. Can you hear me, please?
I can.
Hello.
I can hear you. I can hear you.
Please, can you hear me? Okay, I cannot hear you.
I can hear you. Please, I can hear you. We can hear you.
Hello?
Yeah, I can hear you. I
Okay,
can
I
hear
can hear
you.
you now. I came in really late, right? That's number one. And I was just hearing you were talking about the read and write and the gas and gas fee, which I did not even get properly. So
So up till now you didn't get it.
no, I'm not going to tell you I didn't get it, right? I was not paying attention. So I came in for two reasons. I came in to ask if I could join your community, and the second one, if I get the recording after this class, since it's a recorded class. So I was not just paying attention.
Okay, so I'm the
Attention.
one to answer those questions. One, you're very welcome. Two, yes, it's recorded and you'll be able to get the recorded class.
All right. Thank you very much, Ndifriki.
Okay,
And it's
so
Miriam.
Miriam, you said. Okay, I think that's everybody. So okay, I'm going to give you guys, let's see, if you have any question, like not regarding the class though, like if you have something you want to ask about blockchain, like I'm going to give, like, let's use from now till 11:30. So I want to answer any broad question. Like there's no question. I don't think I'll not treat any question like a finished question. So just ask, don't be shy if you have any question. I know it's a new space and you should have questions. So even if it's the working mechanism, how it works, like this, I want you to ask questions. Like even though you think they are far-fetched and unrelated, but ask and wait.
I'm
Nobody
sorry
has.
sorry to interrupt.
Yeah.
Mariam, the community link is in the chat. So please just
Okay, bye. Go ahead.
Okay, yes. About the smart contracts that you spoke about earlier, I did not really
Yeah.
get that part.
Okay. So now, let's see now. Okay. What are smart contracts? Smart contract. Let's see. Okay. Do you know any level of programming? Do you write any level do you know anything about coding or stuff?
Yeah, just a little, but not.
So what do you know? Which language do you write? A little.
It's just Python.
Good. So, okay, Python. Let's say you want to write a program that will print your name.
Yeah, I'm familiar with that one.
Yeah, so that's just what a smart contract is. So it's just like in Python, you have you can write, is it a script? Even in JavaScript, you write a script. You understand? So it's just it's a piece of code. A smart contract is a piece of code that executes. That is a piece of, yeah. It's just, I'm trying to just, it's just a piece of logic written on the blockchain. That's what a smart contract is. Like, let me just show you an example. You know, in the way in Python you can write code that will print your name. It's the same thing in Solidity. So let me show you what I mean, because yeah, I'm just using so Remix is a developer's environment. It's a virtual developer's environment. If you are building applications on the blockchain, we could do this in my terminal, but I just choose to use Remix because it's a bit easier for you to understand. I accept. I'm using it for learning. Wait, I've not logged. Good. So now, don't think too much. Don't think too much. Don't think too much. I just want to open a new file. Yeah, I'm new to Remix. Thank you. Good contracts. And just create new one. Let's call it Hello World. I think that's the first thing everybody writes. So just like in Python, it's .py, .php.js, Solidity is .sol. That's the language of Ethereum. .sol. So I think we need Pragma good, Solidity version 0.8.30. I think it's up to 30 now. So we want to write a contract. Hello world, good. Say hello world. Okay, the greeting is hello world. So this is a simple, this is smart contracts here. Let me increase my screen size. So everything you want to happen will be in between contracts, the name of the contract, and this is it. So here I just defined a string in storage. So in smart contract, we have three types of storage. We have the storage, the memory, and the call data. So the storage is anything on storage is stored on the blockchain. The storage is the blockchain itself. It's very expensive to manipulate, meaning you will need gas to manipulate the storage. Then the memory is just it's the memory used during the lifetime of a function call. So after the function call, it is discarded. So it's not expensive. It's almost costless. But when you want to alter the storage, that's when it will create. So let me explain this thing very well. So let me take this thing out. This was auto-generated. Let's have a function. Let it call set greeting. So it should take in a string. The string should be stored in memory. Let's call it greeting. So it should be external. That should be only be able to be accessed from outside the contract. It is external function. It doesn't return anything. So what should happen is we should say greeting should be equals to greeting. Please, do you guys understand?
Yes.
You understand this simple function? So it's a function. The name is set greeting. It takes in an argument greeting that the user will pass in. Then we set the state variable greeting to what we passed in, and this function is just going to return greeting. So we have to compile. Let me auto compile it because it has to compile before it runs, and now we can deploy our contract. So when I click deploy, it's going to add it to the blockchain. You see, we have it here. So let me increase the screen size so that we can see what's happening here. So you see our two functions. This function is greeting. This function say. So this even here it shows you this is a write function from the color. It's a write function, and this one is a read function. So we can We can just say good morning. Now, if we click here, you see it's empty string. You see here it's empty. But the moment I write good morning, you see it has been successful. This is a test environment. That's why my wallet is not pumping up. It has been successful. Now, if I click on the read, you see it returns good morning. If I make it afternoon and I do it, if I call it back, it says good afternoon. So in essence, a smart contract is a piece of code that is written and runs on a blockchain. You understand? A smart contract is basically code that runs on the blockchain. So it's called that because once you call it, once the conditions are met, no matter come rain, come sunshine, it will happen. So okay. So who else is on this call? Genesis, any question?
No, sir.
Okay. In the free, how many days do I have? How many classes do I have?
Okay, so at the end of this class, we're supposed to depend on them. So I wanted to ask the students, right? By Thursday, you have an option. Either we can move straight to Dune and start analyzing, or you can take one more class to just try and understand what smart contracts and Web3 and is all about, right? Where Aji comes and probably writes some codes or just something small, so that when you are visualizing this data, these hashes, because you will deal with hashes, when you're analyzing events, when you're beginning to actually analyze smart contracts, not general data that you will see on Dune, you'd understand it better and you will not struggle with it too much, right? So I want you guys to answer, because if you move on straight to Dune, you will not understand. You will understand ES, you understand SQ, maybe a few things, but when you start doing the actual things, you'll not understand. So do you want to actually just take one class, just sacrifice one day, probably a boring day, as he just comes and explains everything, shows you how to write code, you do you just code along and just get basic understanding? Or should we just move to Dune? Which one do you guys want?
The first one.
Everybody else, please, can everybody vote? Okay, first one, please. Okay, no problem. So, Aji, I think you have one more class where you just come and just discuss, write some smart contracts to make it easier for them. What do you think?
Okay. Okay. So I'm thinking Thursday or Friday.
Which one? Which one is convenient for you?
Let's see. Let's do same time on Thursday.
Okay, no problem then. So I will get the message out to everyone. Also, sorry, I know that Genesis, you were in the same class with some people in Dune Africa who are struggling to understand the introduction to Web3. I might forget to message them, so please, I would like you to spread the word if you can, right? So
Okay,
same time on Thursday. So same time on Thursday. Yeah, same time on Thursday.
Okay, so thanks for having me, guys. It was awesome sharing knowledge with you guys. So do take care and have a wonderful day, guys. Cheers.
Okay, thank you. Thank you, Aji. Thank you, India.
Thank you, everybody.